Hello everybody. Now in today's question we have to find out electric field intensity at any point on the axis of uniform charge ring. So let us suppose we have a charge ring, circular charge ring, and we have to find out electric field at its axial position. Let us suppose at point P we have to find out electric field. So consider a circular loop of wire of radius A. So the radius of this circular wire is A, and let us suppose plus Q charge is uniformly distributed over its circumference. Now we have to find out electric field at point P, where the distance from O to P is R. This distance is R. Now we are considering a small length element of this circular wire, and let the length of this element is dl. Small dl is the length of this element. So if the length of this element is dl and total charge on this whole ring is q, then the charge on this small element will be, so charge on small element will be total charge on ring, that is q, upon circumference of ring, that is 2 pi a, into length of small element. So the charge will be dq charge will be q upon 2 pi a into dl. Now if we find out the electric field at point P, so the electric field at point P will be in this direction, because if we consider a plus Q charge, then the electric field due to this plus Q charge will be outward, and in this direction the electric field due to plus Q charge will be in this direction. So the electric field due to this positive plus dq charge will be in this direction, that the direction of de is in this direction. So the magnitude of de, the magnitude of small electric field due to this small element will be dq, yeah, or 1 upon 4 pi epsilon naught dq upon r square. And r, what is r? The distance between this small element and this point P. So the distance between, if it is a, it is r, so the distance between length element and point P will be r square root r square plus a square. So the formula of electric field will become 1 upon 4 pi epsilon naught dq upon r square plus a square का whole square, because since electric field due to point charge is 1 upon 4 pi epsilon naught q upon r square, that's why the electric field due to this small element will become 1 upon 4 pi epsilon naught dq upon r square plus a square. So on solving it will become 1 upon 4 pi epsilon naught dq upon r square plus a square. Now as we can see, the electric field due to this element is in this direction. Let us suppose there is, after finding this value, we consider the next small element in here. Now the electric field due to this component will be in this direction. and if electric field due to this component is this direction, and then after that we consider there, so the whole electric fields will be in conical shape here. So we have to check the components in this direction, in horizontal direction and in vertical direction. So we will we will make components of this electric field. So if this electric field is making theta with the horizontal, then this will also become theta because of vertically opposite angles. So the component of this electric field, if you don't know how to make components, please let me know. I am thinking that you know how to do components, that's why I am starting. I'm just to save time, I'm just making components. So the component of this electric field along horizontal direction will become d cos theta, and the components in this direction, in vertical direction, because of this electric field will become d sin theta. Similarly, the component of this electric field in this direction will be d cos theta, and the component of this in vertical direction will be d sin theta. So as we can see, these components, these vertical components are equal in magnitude and opposite in direction. So these components will cancel out each other, and the components in horizontal direction will add up to give the net electric field at point P. And the net electric field at point P will be in direction of OP, O to P, in this direction, in horizontal direction only. So let's calculate electric field. Let's calculate electric field at point P, total electric field. So total electric field E equal to sum of or integral of dE. So what is dE? Now putting value of dE, putting value of dE, 1 upon 4 pi epsilon naught. And not only dE, the component of dE, so dE cos theta. So on putting values of dE will become 1 upon 4 pi epsilon naught dq upon r square plus a square, and the cos theta and the value of cos theta is, so we can see in this triangle, if this is angle theta, then it will become 90 degree. If this is 90 degree, then it is hypotenuse. So the value of cos theta is base upon hypotenuse. So base is r and hypotenuse is root r square plus a square. So the value of cos theta will become r upon root r square plus a square. On solving this, we will get 1 upon 4 pi epsilon naught, and in integration we got r dq upon r square plus a square to the power 3 by 2. Now this dq is elementary charge. So putting value of dq, we get, as we have find out that dq is q upon 2 pi a into dl. So putting this value, we got r upon r square plus a square to the power 3 by 2 into the value of dq is q upon 2 pi a into dl. So our next line will become equals to, we are taking constants out of the integral, and we will got 1 upon 4 pi epsilon naught r upon r square plus a square to the power 3 by 2 into q by 2 pi a and in integration only will dl. So on integrating dl is the length of small elementary, and then if we take the whole length, integral dl matlab whole length of the circular wire, so it will become 1 upon 4 pi epsilon naught r upon r square plus a square to the power 3 by 2 and q upon 2 pi a, and integral to dl will become 2 pi a. So this 2 pi a will cancel out this 2 pi a, or we can write here integral dl equal to 2 pi a. So it will become 2 pi a will cancel out each other, so it becomes e becomes qr upon 4 pi epsilon naught r square plus qr upon r 4 pi epsilon naught r square plus a square to the power 3 by 2 at p. E at p will become e at p. So if we consider at the center, if we consider a coil, and if we find out the electric field at this point, and if we want to find out the value of at this point, so at this point the value of r, this r will become 0 because we are shifting this point to our center, so this r will become 0. And if at center r will become 0, so if a value of r is 0, then on putting r 0 in place of r, e will also become 0. So at center there is no electric field, and if when r is very greater than a, when r is very greater than a, then we have to 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 neglect this a square, because it will become negligible. The value of a square will become negligible as compared to r square. That's why we have to neglect a square. So the electric field become e at p will become qr upon 4 pi epsilon naught r square to the power 3 by 2. And on solving this 2 will cancel out this, so it will become r cube, and 1 r will cancel out from this, so it will become e will become q upon 4 pi epsilon naught r square. So we can say that um, when we can say that a circular loop, as a circular loop of charge behaves as point charge when the observation point is at a very large distance from loop, because what we got here, we got the formula due to this circular charging is the same formula we got from a simple simple unit charge, or we can say formula of point charge. So we can say for large distances a circular ring will behave like a point charge. Thank you.